Okay, here we have a HD that has a blocked low flow sensor. You can't see this very well, but we're applying 8 gallons an acre at 5 miles an hour. And you can see our low flow sensor has failed, but our total flow sensor is still working. So we're still hitting our rate, 8 gallons an acre commanded and 8 actual. And our pressure stability is 99 at 27 psi, just absolutely nailing it on the pressure stability there. So I'm going to reduce my rate here down to 4 gallons an acre and see if we get, so our HD right there just shut off. And the reason is because that low flow sensor is the only thing it's going off of, and it got to be such a low rate it didn't trust it anymore, and so it just shut off. It went to -5, -5. So if I increase my rate or speed up a little bit here, there, now it turns back on. You can see the ball position opened up and we've got flow again. So so you can still run with a failed low flow sensor. It just depends on if at low rates it's going to struggle or shut off on you. Okay, and we changed the HDs out here, and we're running 5 gallons an acre now at 5 miles an hour. And you can see here our low flow sensors working now, but our total flow is showing 0. We're still hitting our rate 5 and 5, but we're not getting any feedback from our total flow sensor. But as I increase the rate, I'm going to actually type in 20 gallons an acre here for a rate. You can see the low flow sensor is going up, and I'm going to actually bump it up to 25 gallons an acre. You can see now it knows that the total flow has failed, and we're commanding 25, but we're only getting 15. And this is where that magic 25, 20, ball position comes into play here, is that because when we open farther than 25, it starts to accept that flow from the high flow chamber. And since our total flow sensors failed, it doesn't know how much is going through that chamber. So it's saying, I'll open to the ball position to 25, and that's it. So it still is applying some, but it's not applying the full amount. So you could either stop and fix it, or slow down, or just live with applying a partial rate there until you fix that total flow sensor. So if we would slow down to where the ball position goes less than 25, you'll hit your target rate. And we'll see that here, 12 gallon target. We're hitting our rate, and the ball position is only at 12 or 13. So that's how that works. Okay, we don't have any HD plugged in yet. So right now we're going to plug in an HD that has a bad motor in it. That's, sorry for that. I'm going to show you what a bad motor looks like. So you can see the actual and commanded ball position here are not jiving with each other. We've got a 31 as actual and 0 as commanded. So that should turn yellow. If you were to be operating like that, that would turn yellow. I don't know if it'll do it here on the test stand, but we'll maybe give it a second here and see what happens. So I hit reset modules, and we're detecting devices. And I can hear the HD trying to find its home. And it's doesn't look like it's going to do that for us, but you know something's either wrong with the head or the motor if these two numbers are not jiving with each other. Okay, here we've got a HD running that has an issue. We're commanding 5 gallons an acre, but we're actually applying 58. So major problem there. Our total flow is giving us a reading. Our low flow is not. We can see our commanded ball position is 0, but it's wide open. So that would be indicative of a stuck head, most likely. Could be a motor, but I would maybe say a stuck head. And look at our supply volts, jumping around, which would also be indicative of a potentially a bad circuit board within the HD itself. So so we would have to try a few different components on this HD to actually figure out which one it was, but just wanted to show, you know, this is basically running wide open. Our pressure is way down there because we're probably maxing the pump out on this little test stand, but we're way over applying on our rate. So I just want to point out a couple things here quick before we close this session out. So this average flow stability here, you know, this is for the master module, since it's above the dark line. If this number gets below 85% flow stability for the system, the HDs will start to try to compensate for some of the choppiness that's causing that lower flow number. So about 85%, they'll start trying to compensate, and you will possibly see that on your field view where if you pull up the liquid map, you'll start to see some choppiness as that flow stability degrades in your application map. One other thing I just want to point out, and I know we've talked about this in some of the other sessions, is to watch out for return lines that are blocked on your hydraulic fertilizer pumps. So the tip that you plug into the tractor can get blocked or partially blocked, and just momentarily reversing flow from the lever in the cab for a second and then back forward again can unblock that tip. If it's really bad, this happened to us on our setup out in the field a couple of years ago, where that didn't do the trick, and it was blocked so tightly, that return tip, that we actually had to crack the fitting, bleed off the pressure, tighten it back up, plug it back in the tractor, and away we went. My dad was very skeptical that was going to work, but that's actually what ended up doing the trick for us, because our fertilizer pump, even though it had pressure, it wasn't allowing oil to flow back to the tractor in that case. So that wraps up the session for the HDs.